Element 34 on the periodic table of elements is selenium. This is Norris Teaches Science, starring me, Mr. Norris. This is going to be another physical science edition video. Today we're going to continue talking about some physics concepts, and this physics concept is known as work. So your goal for this video is I can calculate work when given data observations. So, like always, we usually start with a definition. What is work? Well, first off, work is a transfer of energy. It means energy going from one place to another. It occurs when a force makes an object move a distance. And if you don't know what a force is, I have a force video, friction video, force of gravity videos that you can watch before you watch this. But it is using force and it's using distance. So when is work done? When is work not done? In a sense, in a physics idea, we're not talking socially, we're talking about physics. Work is done when an object moves in the direction of a force. So one, there has to be a force. Two, there has to be movement. And three, the movement has to be in the same direction as the force. No work is done if one, there's no movement. If there's no movement, there's no work. And two is if the force is in one direction, but the movement is in a different direction. That doesn't mean work is done in the sense of physics. Remember, we're talking physics here. So let's look at here and see if we can figure out, is the situation talking about work being done, or is the situation talking about no work being done? So the first one, pushing on a book forward and the books move forward. All right, this has work done. Reason why, there's movement, and the movement is in the same direction as the force. All right, two, pulling on a wall and the wall doesn't move. What do you guys think? Well, no. No work's being done here. Reason why? Because there's no movement. Situation three, you push on a car forwards and it rolls backwards. Here, no work's being done. Reason why? Yes, there's movement, but the movement is in the different direction than the force. The force is forward, the movement's backwards. That means it's no work. The work does have a formula, so algebraically you would say work equals force times distance. Or using our symbols, a capital W equals a capital F times D. Sometimes people write it like this. Or they can write it like this. All right. It all means the same thing. So the capital W means work, and the unit for work is joules. The capital F means force, and its unit is newtons, and the lowercase d is distance, and its unit is meters. Now, if we take this formula and we place in my triangle method over here, since force and distance are being multiplied, that means they're going to be next to each other in the triangle at the bottom with work at the top. So let's do a couple examples. We're going to do three. I'm going to do two. You're going to practice one, then we'll go over it. So it says a man weighing 750 newtons. Remember, we circle our numbers. Climbs a flight of stairs 5 meters high. How much work did he do? So first thing you ask is, what is being asked of you? And that's work. So you place work, the capital W, in the work area. All right, 750 newtons, that's our force. So we're going to place that over here. And our 5 meters is our distance, so we're going to place that here. So we do our multiplication and we get 3,750 as our value. But remember, you have to show your work, you have to get the correct answer, and you need to give a unit. And the unit for work is joules. All right, let's do another example. Kayla does 40 joules of work while pushing a shopping cart 30 meters. We're trying to figure out how much force was applied. So since we're trying to find force and we're using work and work is given, we're going to use the work formula, and force goes right here. At the top goes the work. The work was 40 joules. And at the bottom was our distance, which is 30 meters. We do our math and we get 1.33 newtons. How we got that is because since the numbers are on top of each other, we divide. When they're next to each other, you multiply. When they're on top, you divide. And so it was 1.33. It's actually 1.33 repeating of newtons of force. All right, this is practice number 3. Pause the video and try to solve this one on your own. See if you can do it. Did you do it? Did you pause? I hope you paused. All right, I'm going to go over. It says David pulls a 450 Newton sofa up the stairs, producing 25 joules of work. How far did he pull the sofa? So we're trying to find the distance. So we're going to leave little d in the triangle. At the top here, we go our work, which is 25 joules. And at the bottom would be the force. And the force here is 450 newtons. Now the numbers are on top of each other, so we divide. We would do 25 divided by 450. All right, because it's always top divided by bottom. And we would get 0.06. I think it's 6 repeating. I can't remember the exact amount. I did this beforehand as our value, and we're going at distance, so it's meters. So we did not get that far. That's about, I don't know, 6 millimeters. All right, but that's work. And I hope you learned a little bit about calculating work, what work is, how work applies to in a physics sense. Come back for another video, and I'm Mr. Norris, and I'll see you at the next one.